Okay, let's have a look at 3.2 and get comfortable with this kind of question because I've seen it a couple of times. So the following consists of two different series. So what they've done is they've meshed two series together. Let's have a look at this quickly. If we look at the first term, our first term is 27. The second term is 2. Right, the next term is minus 9, and then we get another 2. Right, then the next term that you have is positive 3, and your next one is a 2. The next term that you have is a minus 1, and as you can guess, let's put this in a different color because it's not given. The next value is going to be a 2. So we have two series. The one on top, we'll still figure out what kind of series this is. So this one, we'll figure out what kind of series it is. But the one at the bottom, that is just a series of consecutive 2's. Okay, so let's just have a look at this quickly. When we want one term 1, as we look at the series above here, the series above, term 1, that is this one. And then term 2 was this one. Term 3 over here, term 4 here, term 5, term 6, term 7, term 8. Okay, so what I notice here is that every odd number that's on top, every even number, that's going to be another 2. So if so they asked us for term 15, right? So that's odd. If it was an even number, if they say determine the value of term 16, we'd know that's going to be a 2. Okay, so what we are figuring out now is that term 15, that is going to be a value that's going to fall in this sequence above. So we're going to have to kind of figure out which value in the top sequence. Let's first figure out that term 15, which place value that is on our sequence above. So there's 1, there's 3, there's 5. Next is going to be term 9, and then you're going to have term 11, and then you're going to have term 13, and then you're going to have term 15, and term 15 is the one that we want, right? So if I look at the sequence above, let's count quickly. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So what the question actually wants from me is to determine the 8th term on the sequence above. Right, let's get into that. So we're going to determine the 8th term in the sequence above. The first thing we need to do is determine what kind of sequence. So they didn't tell me what kind of sequence. So I need to find the kind of sequence that it is. We have two options. We either know it's arithmetic or geometric. If arithmetic, we know there's a constant difference. Okay, so let's check for the constant difference. Constant difference, so it's second minus first. So I'm going to say minus 9, and I'm going to subtract 27, and that is going to give me negative 36. Now I'm going to take next consecutive, so I'm going to take 3, and I'm going to minus the minus 9, and that's going to give me a positive 12. Right, so clearly these values are different. What does that tell me? There is no consecutive difference. Okay, what did I just do? Okay, let's talk about that for a second. Okay, let's see quickly. I took this 9, this negative 9, and I subtracted it with this 27. I subtracted consecutive values, second minus first, to get my difference. My difference was negative 36. Okay, then I went to the next consecutive values, right? Let's just change the color quickly for us. So then I took the next consecutive value. So I took the 3, and I subtracted the minus 9. And that gave me this value over here. So my differences are these two values. Clearly they are not the same, so there's not a constant difference, or a first constant difference at least. So this is not an arithmetic sequence. So all of this, let's just get rid of it. Doesn't really help me. Okay, what I'm going to do now, because clearly there's not a constant difference, maybe this is going to be a geometric series. So in order to find geometric, we need to find r, and we know how do you get r? You always know it is term 2 divided by term 1. So arithmetic, consecutive terms second minus first. Geometric, consecutive terms second divided by first, right? So I'm going to take my negative 9, and I'm going to divide this with my 27, and that's going to give me a negative 1 over 3. Right, let's use the next two. So again, we're going to find r. right? Oh, that's a r. We're gonna find r, and we're gonna say term 3 this time, and divide it by term 2. So term 3, that's going to be my positive 3, and I'm dividing with term 2, which is my negative 9, right? And that also simplifies to minus 1 over 3, right? So what did we figure out? We figured out these two values are the same thing, okay? What did we do again? We said consecutive terms. So we said the minus 9 divided by the 27, okay? Minus 9 divided by 27, and that gave us the negative 1 over 3. Then we went on to the next pairing. So we took the positive 3 and we divided it with the negative 9. Again, consecutive terms, right? And that also gave us minus 1 over 3. So what does this tell me? There's a constant ratio. So there's not a constant difference, but there is a constant ratio. Therefore, we know the series is geometric, right? So what do we want to do? We want to find the eighth, right? Because the eighth term of the geometric series corresponded to our 15th term of the original series. So let's find the general term. So we're going to find Tn of our geometric series above over there. So Tn equals, so this is another formula that will be given to us on a formula sheet, but I'm sure we know it as well. So it's equal to A R to the power of n minus 1. All right, so let's fill those values in. A is our first term. In this case, that's going to be our 27. Our R, we've already figured that out, is negative 1 over 3. And n is going to still be n minus 1. Okay, again, we figured out that term 15 corresponds to the 8th term in our geometric series. So we're going to go with this formula, and now we're going to substitute 8 in n's place. So we're finding term 8, and we're going to say 27, open bracket, 1 over 3. This needs to be negative, to the power of 8 minus 1. Okay, let's go put all of this in the calculator quickly, and let's see what the calculator says. Right, calculator says this is negative 1 over 81. So our 15th term, all right, let's go back to our question over here. Our 15th term in this sequence over here corresponds to the 8th term in our geometric sequence, and we found that out to be negative 1 over 81. All right, let's leave the next part for the next video.